Greetings, math fans. All right, so what we're going to do today is we're going to be finding information given either an F or an F prime graph. Okay, so when I say finding information, I'm talking about talking about concavity, talking about max and mins, etc. Okay, so first one's actually pretty easy. First one is given just the f of x. All right. Again, this is really easy, but it's okay. Let's do it. Okay, so this is what my graph somewhat looks like. Ooh, that's a rough sketch, but good enough. All right, so let's look at a couple things here. First of all, f prime is positive where? Okay, well, what does f prime mean? F prime means the slope is positive of this graph. So the slope is positive between 0 and 2, right? Okay, f prime is negative, or we could say less than 0, it doesn't matter. And then, of course, between negative infinity and 0, union 2 and infinity. Okay, that's pretty easy. And then, of course, we can say f prime is equal to 0 at x equals 0 and 2. If I ask you for coordinates, just plug it back in the original problem, which you just look at, obviously, you're given a graph, so it would be at 0, negative 1, and 2, comma 1. Again, make sure you're careful, right? These represent points. These represent intervals, the top two. Okay, what about f double prime? Where is that positive? We'll just say greater than 0. Well, f double prime means concave up. Well, where's it concave up? It's concave up between negative infinity and 1, right? Because here it is, concave up. Let's look at it. Concave up. And what happens right here at this point? It's an inflection point, right? So it changes concavity. So it's between negative infinity and 1. Okay, so f double prime is less than 0. Then, of course, between 1 and infinity. And where do we have f prime equal to 0, which is our inflection point, at x equals 1. Okay, and the coordinate is 1, comma 0. Okay, and of course, again, that is an inflection point. Okay, that's pretty easy. All right, it's always easy with the f graph. This is where it's a little more challenging, is with the f prime graph. So let's sketch that one out here real quickly. Okay, so this is given f prime of x. Okay, that's your graph. Now, you guys, you need to remember this is the slope graph. So when it's above the x-axis, it's a positive slope. When it's below the x-axis, it's a negative slope. That is so huge. This is one of the more confusing things that you have with graphs. Okay, you've got to remember that. Okay, it's above the line, it's a positive slope. It's below the line, it's negative slope. So let's talk about, again, we're talking about the f graph now. All right. So f graph. This is our explanation of the f graph. That is so huge. You got to remember that. Okay, so you're going to say, how about a couple things? F is increasing. Okay, what does it mean to say f is increasing? Does that mean it's got a positive slope? So where does it have a positive slope? It's where f prime is greater than 0. So it has a positive slope between -1 and 1. Right, where it's above the x-axis, union 3 to infinity. All right, and where is f decreasing? That's where f prime is less than 0. And of course, that's below the x-axis, so between -infinity and -1, union 1 to 3. All right, not bad. Let's look at some of our local extrema, or relative extrema. And what does that mean? That's where f prime is equal to 0. Okay, so it's equal to 0 at x equals -1, right? Again, we're looking at the f prime graph. Where's equal to 0? At -1, at 1, and at 3. So what are these? Are these relative maxes or mins? Well, remember, when I asked you guys to learn that verbiage, I said f prime of x is equal to 0 at x equals blah. Okay, and then I said, and it's changing from negative to positive or positive to negative. That's how you tell if it's a max or min. So look what's going on for -1. Isn't it going from a negative slope to a positive slope? Right? Here it's negative slope to a positive slope. So use your hand and go, oh, negative slope to positive slope. Oh, okay, that's going to be a minimum value. Okay, so this is a relative min. And look at the 1. It's going from a positive slope to a negative. So take your hand, go positive to negative. That is a relative max. And then 3 is going from a negative to a positive. So that is going to be another minimum value. Okay? So that's kind of how you tell, read this graph. Got a couple more things here. Let's talk about where is it concave? Up. Remember some of the verbs I had for this. It's concave up where f prime is increasing. Where f prime is increasing. Okay? And where is this increasing? It's when the slope is positive, right? Okay, when the slope is positive. Because remember, the second derivative is the derivative of the first derivative, right? So it's the slope of the first derivative. So it's concave up when the slope is positive, when f prime is increasing. And where is it increasing? It's increasing between -infinity and 0. Union 2 and infinity, right? Going back, it has a positive slope between those values. So 2 and infinity. All right, and then it's concave down where f prime is decreasing. And remember, where it's decreasing, it's a negative slope. Where is it going down? Where is it decreasing? Between 0 and 2. Okay? Very important, but a little tricky. To remember, it's that f prime graph is a slope graph, and we're always talking about, again, this is always an explanation of the f graph. That's usually what I'm looking for. Okay? All right, so let's try one more here. All right, so this is a little tricky, but this is another f prime of x graph. All right, so we have two holes here at 0, 1, and 0, -1. All right, so let's see what's going on here. First of all, let's talk about where it is, where F, so again, we're talking about F. Where is it increasing? Okay, well, what does that mean where it's increasing? Okay, it means basically where F prime is greater than 0, right? That's where F is increasing, because again, we're looking at the slope graph. This is F prime of X is the slope graph, so it's increasing where F prime is above the x-axis, and it's decreasing where it's below the x-axis. Okay, so it's increasing between -1 and 0, union 2 and 4. Pretty easy. Decreasing where F prime is less than 0, so it's decreasing between -2 and -1, union 0 and 2. Okay, we have a, let's talk about extrema now, right? Relative, we'll talk about relative, okay, extrema. We have a relative max and relative min. So remember, it's where it's equal. This is where F prime is equal to 0. All right? So where's it equal to 0? Well, here's one spot right here. And it's going from negative to positive. All right? So again, take your hand. Go from negative to positive. You have a minimum point. So you have a relative min at x equals -1. And of course, you also have one at 2, right? From negative to positive. So at 2. And what about relative max? Okay, what can you guys tell me about this area right here? Well, it's not really defined there, is it? So you guys agree this is really not a relative max at all because it's just not defined. Well, actually, you're wrong if you thought that. Okay, most people kind of think that. They look at it, they're like, well, it's not defined, Mr. Curvis. And I'm like, well, yeah, it's right, but let's look at this graph right here. What can you guys tell me about this, the derivative of that? Oh, it is not defined either, right? It has two different tangents. One has a tangent of negative infinity. The other one has a tangent of positive infinity. This is a cusp. Okay, and then you can also have, right, this is a corner. So think about it. What is this one going to be? This one is actually a corner, right? Because this one's going from basically a positive slope to a negative slope. Okay, because it's above the x-axis to below the x-axis. So this is actually a corner here, going from positive slope to a negative slope. So it's going from positive to negative. That's a max. So there's a max at x equals 0. And that's really how you look at critical values too, right? You look to see where it's undefined, f prime of x is undefined, and also where it's equal to 0. And this is an example where f prime is undefined. Okay? So it's a little tricky, but that's what it is. And all right, and we can take a look at concavity. Where is it concave up? Well, what does concavity mean? It's where f prime is increasing. Okay, and so where is f prime increasing? It's increasing actually between, it's got a positive slope from -2 to 0, union, and then 0 to 4. Okay, so the whole thing is concave up because f prime is always increasing. All right, I want to do one more example here with you, math fans, and this is just another friendly example given a function and to kind of find everything. I think it's just good practice here. Here's your graph. F of x is equal to 6x squared minus x to the 4th. Okay, and let's start out. We're going to take the derivative. and we get 12x minus 4x cubed. And we're going to set that equal to 0. And so we can factor out a negative 4x. We get x squared minus 3 equals 0. So x equals 0 and x equals plus or minus root 3. Those are our candidates. So let's do our interval testing here. 0, negative root 3, positive root 3. This is going to be negative 2, negative 1, 1, and 2. Okay, and we test everything out here. We wind up getting plus, minus, plus, and minus. So that means the negative root 3 is going from positive to negative, so it's going to be negative root 3, comma, 9. And that's going to be, of course, a relative max. And then the 0, it's going to be 0, comma, 0. And that's going from to negative to positive, so it's going to be a relative min. And then the root 3, comma 9, again that's plugging back into the original equation to get our y value. And that is going to be a relative, it's going from positive to negative, so it's another relative max. Okay, not bad. Let's get our inflection points here. So we're going to take the second derivative, f double prime of x is equal to negative 12x squared plus 12. So 12x squared equals 12. X squared is 1, so x is plus or minus 1. Candidates for inflection points. So negative 1 and 1, negative 2, 0, and 2. And we do our interval testing, and we get negative, positive, negative. So that negative 1, first of all, let's look at a couple different areas here. These are both definitely inflection points. So it's negative 1, comma, negative 1, comma 5, and 1, comma 5. And so it's going to be concave down between negative infinity and negative 1, union 1 to infinity, and concave up between negative 1 and 1. Oh, by the way, on the left here, it's increasing between negative infinity and negative root 3, union 0 to root 3, and decreasing between negative root 3 and 0, union, it's a little messy here, sorry, union root 3 to infinity. Okay, so that's kind of all our information for that. And now what I want to do is I want to make a quick sketch of what this thing looks like based on that information. So we're going to kind of make a graph here. And plot our points. So we have, and we're kind of estimating the negative root 3, right? It's a little bit, like root 3 is a little bit less than 2, and negative root 3 is a little greater than negative 2. So let's kind of plot some things out here. Go up to 9. All right, so negative root 3 and 9. It's about here. And 0, 0. So let's label this 2. This is a max. 0, 0 is a min. Okay, and then we have another max over here. Let's plot our inflection points. 1, comma 5. So I'll label it with an I, and 1, comma, or negative 1, comma 5. Those are actually really important. Those concave for inflection points, it really does help us graph this accurately. All right, so do you guys agree that, First of all, we have a maximum point. And if you look at, it's increasing between negative infinity and negative root 3, but it's also concave down. Okay, so this is the deal, a little rough sketch, but it's going to look something like this. It's going to be concave down to here. Okay, and then from negative 1 to 1, it's concave up. Okay, and then from 1 to infinity, it's concave down again. Okay, to that maximum point. And there's your graph. Okay, so it's kind of a rough sketch, but again, the concavity I think really helps when you're doing these graphs. All right, so hopefully that was just a little more information, just another example to help you guys out. Okay, my friends, this is the last example. This is again a quick sketch of f prime. It is so huge that you recognize that this is f prime. Okay, I cannot stress that enough, because if you assume it's the wrong thing, everything is wrong. Every single problem that you are going to get that refers to this graph is going to be wrong if you don't realize that is an f prime graph. Okay, so what I want you guys to do is, first of all, we're going to describe f of x. Okay, so you're given the slope graph, and you're going to describe f of x for me. Now, this is really important. I'm going to put a nice little asterisk here. Is you can only refer to f prime of x when you're trying to describe the reasons. So we can only refer to f prime of x when given a reason. So when you're saying, oh, it's a max or min because f prime is changing from negative to positive. So you can only refer to f prime of x. Okay, and I'm actually going to put this on here. You don't refer to f of x or f prime, double prime of x. Or don't talk about the slope either. Okay, why would you talk about the slope when you're talking, this is the slope graph. So don't say the slope is positive, negative. Tell me f prime is positive, f prime is negative. Okay, but I don't want to see anybody referring to the original graph, and I don't want to see you saying, oh, it's concave up because f double prime of x is greater than 0. I don't know anything about f double prime of x. I only know about f of x. So you're not allowed to refer to anything but f prime of x, because that is the only thing that you're given. Okay, so very important. All right, so let's talk about this graph. I have a relative. Let's talk about a relative extrema first. So I have a relative max at x equals 0 and 4. Right? I don't know coordinates now, right? If I ask you, well, what's y coordinate? You really don't know that because you're just given the slope graph. I know my x values, but I don't know y values. What does that represent? It just represents the slope, right? So I have no coordinates. So you're just going to give me x values here. So relative max at 0 and 4. And you know it's 0 and 4 because, let's put this in red here. This is a positive slope here, and this is a negative slope. And so take your hand to going from a positive slope to a negative slope. That's a maximum value. So that means it's going at 0, x equals 0. It's going from positive to negative. And at 4, it's going from positive to negative. Okay, that's why I have a relative max at 0 and 4. And just give you reasons. So, since f prime of 0, well, of course, here I'm going to just write and f prime of 4 equals 0, and f prime of x is changing from positive to negative at x equals 0 and 4. Okay, got all the words in there. Okay, and that's what you need. And notice I've just mentioned f prime of x. Didn't mention anything else. Okay, so you're going to have a relative min. And again, take your hand. You're going from negative slope to a positive slope. So am I going from negative red mark, I have a negative here and then a positive on top. So I'm doing that at x equals -2. and positive 2 and 6, right? That's where it's going from negative to positive. So then you'll say since f prime of negative 2 and f prime of 2 and f prime of 6 equals 0, and f prime of x is changing from negative to positive at x equals negative 2, 2, and 6. Okay? That's pretty easy. Okay, let's talk about where's f of x increasing. Okay, so again, this is our main goal here, math fans, right, is we're describing f of x. So that's why we got a relative max and min. Again, this is not relative max and min of f prime of x. Doesn't make sense. Why would you find the relative max and min of f prime of x unless you're talking about something different, which is concavity, right? Okay, well, let's go back to where is f prime or f of x increasing. Think about it. Where f is increasing, doesn't that mean the slope is positive? Right? Where the original graph is increasing, the slope is positive. Okay, and where is it positive? Well, look at I wrote the plus here, right, and the minus here. Okay, when it's a positive slope, or when f prime is greater than 0, it's increasing. So that's what you're going to tell me. So it's increasing between negative 2 and 0, because it's above the x-axis. Between negative 2 and 0, union 2 and 4, union 6 and infinity. Okay, since f prime of x is greater than 0. Pretty easy, right? F of x is decreasing, and it's just where it's negative slope. So from 0 to 2, union 4 to 6, right? It's decreasing, okay, because that's the only place that has negative slope, and that's because, or we'll say since f prime of x is less than 0. Okay, pretty easy. And let's talk about concavity. So it's concave up. And where is it? You're looking at concave up where f prime is increasing. So because remember, you're looking at the slope of f prime. Because isn't that what we do? We take the second derivative, which is the slope of the slope. So you look at the slope, and where the slope is positive, it's concave up. So look at it's from negative infinity. Negative infinity, and this is of course f of x is concave up, right? Again, I'm not talking about f prime of x being concave up or concave down. I'm talking about the original graph, f of x. So from negative infinity to negative 1, right? And where else is a positive slope? From 1 to 3. And where else is a positive slope? From 5 to infinity. That's concave up. And that's since f prime of x is increasing. Okay, pretty easy. Concave down. Then of course where it's decreasing, so from negative 1 to 1, union 3 to 5, that has a negative slope. So then you say since f prime of x is decreasing. Now, don't get confused between increasing and greater than 0. That's a different story. Increasing means it has a positive slope. Greater than 0 means it's above the x-axis. Okay, so don't get those two things confused. Of course, if I ask you for a point of inflection, which I could, this is again for f prime, so this is a point of inflection. Don't you guys agree a point of inflection is where it's changing concavity? So kind of where we separated those parentheses, like at negative 1, right? That's where the slope is 0. Because remember, we take the derivative of the derivative, so that we're f double prime of x equals 0. So our potential points of inflection, which they are in this case here, is x equals negative 1, x equals 1, x equals 3, and x equals 5. Okay? And those are our points of inflection because f prime of x, well, what's going on here, right? It's the slope is changing, or it's changing from increasing to decreasing. Do you agree with that? Okay, because it's at a maximum or minimum point. So f of x is changing from increasing to decreasing, or decreasing, I should say to increasing. That means a max, right? It's at a maximum point or minimum point. Okay? So anyway, if you notice here, math fans, I only mentioned f prime of x. There's nowhere here where I talked about f double prime. I didn't say, oh, it's concave up because it's f double prime is greater than 0, because I don't know what f double prime is. I have nothing there. So everything is based on f prime of x. It's the same thing. If I gave you f double prime of x, you could talk everything about concavity, okay, where it's above the x-axis, it's concave up, below the x-axis, concave down. You can do that, but you can't refer to f of x or f prime of x. Okay, so very important. All right, one last thing here before I end this video is I want to kind of point something out here. So I'm going to put a kind of a big star here. If I say find x values, what are you going to find? You're going to find just x values. So you're like, well, duh, that makes sense. But people don't look at that. They're like, oh, find x values, and they give me a coordinate. Okay, if I said find f of x or y, that's just y values. Okay, so if it says find f of x, you find y values. If I say find points, that's x and y values. Okay, please be aware of that. Okay, because you're going to lose a point if I say find some points and just give me a y value, or if I say find y values and find points, you get more work, you're going to lose a point for that. Okay, so you got to find the right thing, to go along with everything. All right. Well, that's it, math fans. Hopefully, you guys are good to go with, given functions or given derivatives and finding the information about it, or even making a sketch, having an understanding what the sketch is all about. All right, that's it, math fans. Have a nice day. Adios. Goodbye.